Hello, I'm Jason O'Malley. I'm a Senior Partner Solutions Architect here at AWS. Today, I'm going to be walking you through the demo, near live highlights, every format, every screen with AWS Elemental Inference. So let's dive in. Now, viewing audiences increasingly consume content on social media platforms that broadcasters do not control, and those audiences have come to expect to see immediate clips and reels from live programs that are optimized for whatever device or screen they're watching on. The challenge is that with legacy and manual processes to format clips, those are very slow, and that adds complexity and delay to the publishing process. So what we'll be showing is how AWS services, together with partner solutions from QuickPlay, Tagboard, and Tile Media, make it possible to go from live action to publish-ready content without that post-production delay. Now, how about we look at it in action? Now, first up is our real-time courtside computer vision analysis that unlocks a broadcaster's ability to drive additional data-driven broadcast experiences for the fans. Now, to power that real-time computer vision, we employ a powerful Amazon Elastic Compute Cloud EC2 G6 instance with an NVIDIA L4 GPU that's continuously analyzing the live feed. In this example, we're inferencing using an open source computer vision model. We also have similar approaches that can be handled by AWS partner solutions. Now, on the left, you've got the live SRT camera feed, and on the right, the system telemetry, which includes things like CPU and GPU utilization, memory, and more, so that you can see exactly what the machine is doing. This inference engine is processing between 24 and 30 frames per second, and as shots happen, you can see ball detection, rim detection, shot attempts, and more flowing in real time. Now, if we go to full screen on the video, what you're going to see here is the body position estimation. So what the model is doing is it's tracking the player's full skeletal model, and layered on top of that is shot detection, classifying each attempt as a made or missed shot. This helps us build structured telemetry that feeds the entire downstream experience for the viewer. All right, now let's jump over to the editor app. This represents that fan-facing, data-driven experience part of the demo. Now, on the left-hand side, we see the video feed coming through in the original widescreen format, and on the right, you can see the portrait version of the feed that is being cropped thanks to AWS Elemental Inference. Now, AWS Elemental Inference has a native integration with AWS Elemental Media Live, and it provides AI-powered cropping by analyzing each frame to identify subjects, track movement, and intelligently reframe the landscape video into vertical formats. Below the live feed, you can see the data-driven layer kicking in. Now, every shot becomes a structured event with biomechanics attached. And up here, the event timeline. Each shot is color-coded with a result. Now here's where it gets interesting. So I can click any marker and that'll take me right back to the moment immediately in the stream, in the media package's time shift window, right there in the video player. No clipping, no waiting. Those key moments within the match are going to be there ready to replay immediately. And for an enhanced experience, we can also activate the skeleton overlay and watch as the additional player tracking data from our computer vision server streams in live to this experience. All right, now let's head over to our amplification studio. This represents an agentic clip editing interface that enhances the clip further by publishing to social media and digital destinations. Now I'm going to click on one of these events, and from here I have my options of applying overlays from AWS partner Tagboard's solution, such as lower thirds, score bugs, and branded graphics, and the ability to export straight to social media. Now in a legacy mode, what may have taken a production team up to 30 minutes to clip in the traditional way can now happen in as little as 30 seconds. All right, and our final piece is the AI Studio. This is an extra ace up the sleeve for broadcasters that are looking to reach fans breaking through the noise of social media. So to counter that, this shows how we can add real-time analytics and graphic overlays directly onto the video. So with this AI-driven approach, creating these clips is easier than ever. There's no specialization required, just basic input into this FX agent that then generates broadcast quality results. We can even ask the agent, what can you do? And when it comes back and it tells us with a full menu of things it has the capability to do, such as object tracking effects like lighting the ball on fire, plus multi-format export in vertical, widescreen, and square. The whole post-production pipeline is controlled through natural language. All right, now you've seen the experience. I'm going to give you a quick behind-the-scenes tour of how it works from an AWS architecture perspective. So as you can see, live camera feeds are coming in through AWS Elemental Media Live for the live encoding. Now, AWS Elemental Inference works natively with Elemental Media Live, and it runs machine learning models in parallel, which is producing those smart crop coordinates and clip metadata events. Then we've got AWS Elemental Media Package handling live packaging with that time shift support, enabling the viewer to immediately jump back within the video player to those key moments. And of course, Amazon CloudFront delivers the video to viewers at scale. Now on the data side, Elemental Inference will be emitting events which flows into an Amazon DynamoDB table. In parallel, the courtside vision processor is running a YOLO pipeline on a GPU-based Amazon EC2 instance, pushing a feed of those structured shot events through Amazon Kinesis. Now, both of those parallel feeds flow into the same AWS AppSync API that loads the clips into the content management system from AWS partner QuickPlay and to deliver the experience to the end user. And the AI agent connects to the clips processor via Model Context Protocol or MCP using 8 MCP tools to handle that full pipeline from detection to rendering, and again, orchestrated through natural language, which really expands the access to these powerful tools within your team. And there you have it. That is our demo experience, which includes live action to structured moments to data-enriched highlights to social platforms, all within a matter of seconds. I hope this walkthrough has given you a clear picture of what is possible to transform those live broadcast experiences on AWS. And thank you for watching.